Well, hi, good morning, and thank you for joining me in my shop here on November 27th. So before I was going to start here, I was going to go ahead and replace or augment the power supply filter capacitor, which is located right at the bottom of it's right in here. And I thought, well, that's just such a simple thing. I'll just go ahead and do it and then carry on with whatever it is I'm going to do next to this radio. But of course, like a lot of things, it's more complicated than I expected. Complicated? Maybe not complicated. But have a close look at this. Let's just swing over here for a second, in case you're not familiar. You see the big metal capacitor here. Metal clad capacitor. Kind of always wonder when you get these radios, is that the original capacitor or not? Most of the time it is the original one. Let's get the close-up camera and take a look closely at this. Okay, there we are. Touch out of focus. Let me just pull back a little bit. Well, so when I look at that, it's a little hard to tell just looking at it. Is it replaced or not? The soldering, all that looks pretty original to me. The position of the wires, nothing looks too weird there. Excuse me. But I'm going to grab onto that capacitor and shake it a bit. Oh my gosh, the whole thing is moving. Now you see how it's mounted. You can see the twisted at the bottom there, the twisted tab. So they push that tab through the slot, grab a pair of pliers, and they give it a twist, and it's just not twisted enough. But you need to do a little more with a capacitor like this. Now in some capacitors there's a negative terminal at the bottom of the capacitor. Not with this one. There's no negative terminal. Those three terminals are all positive terminals, I'm pretty sure at this point. Maybe I'm wrong in this, but I'm not. Okay, me being sure doesn't mean anything. The thing of interest here, excuse me, is just, can you see that? You cannot. There is a blob of solder. I'll have to point to it here. Make sure you're seeing it. So up in here, there's a blob of solder soldering one of these twisty guys to the chassis. Very, very commonly done, and that's the negative connection. So I think, and I could even be right about that. Now I'm going to move the capacitor and watch that blob of solder. The whole thing's moving. In fact, you shouldn't be able to move this capacitor if it's soldered. So there's a bit of a story here. Excuse me. That has to be connected properly to the chassis. Solidly connected, I think. So we need to look at what kind of capacitor this is. I could easily be wrong because one of those terminals could be the negative terminal. Because that kind of thing would cause a lot of problems in the radio. Like a lot. If they shook the radio or something and the connection broke just momentarily, you'd really know it. I mean, I think a lot of stuff would come out of the speaker. That hasn't happened, so I'm thinking, well, maybe it's not critical. Maybe one of those terminals is a negative terminal, because I did install another electrolytic capacitor. It's way over here. You can kind of see it there. And there's 3 electrolytic capacitors in this radio, so I think it really amounts to 2 of those terminals, probably the ones with the red wires coming to them. Probably that lower one is really a negative. Hey, what's happening to my voice here? A little dry in our house. So where does that go? That wire goes out of sight back here. There, I think you can see it there. Coming through and connecting to the terminal at the bottom, it looks like a poorly soldered wire, but it's not. It's a wraparound, and the wraparound part. Well, let's check it. check all these. None of them look great, do they? My poor soldering for that. It's good enough, but not the best. So now that wire comes down to this terminal here. It's pretty solid. Is that a grounded terminal? I don't think so, because boy, you look at this resistor and the other end of it is clearly onto a terminal here. Right here onto a chassis terminal. So no way this is a chassis terminal. And there's no way that this, so this can't be the ground wire. Okay. The other two got red wires coming off. Is there 4 electrolytic in here? We got to take a look at the can. Okay, this is a little tricky to do. The words on the can are in a position, the capacitor can, that are really hard to get at. Let's see if we can see them here. Looks like 10, 10, and 20. So we've got 2 10s at 450. And then 1 at 20. 20 is the bypass, or the output. Well, isn't that what this is? Then this is a 10 over here. Must be 4 capacitors. Well, that's interesting. What that means then is all 3 of these terminals down here are positive terminals. Oops. And that ground connection is what the radio's relying on. Yikes. It is interesting. It's not as simple as I thought. I think maybe just look at the schematic here and see if we can't find all those capacitors. Okay, so we started the power supply, and here's the 2 10 microfarad capacitors. You can see the square and the triangle. I don't know if you noticed, but you could see those on the side of the can. So 2 10s there, and there's a 20 up here, and it's very, very common for all that to be packaged together in one container like it is. It's very convenient for the radio designers. So 20, but this is a low voltage version of it here. I think it's a 25 volt. This is not the one I changed. There's another electrolytic in here. That's over here, C23, which is the queller of the screens, and along with its brother, the 0.1. I replaced these two. That's the 10 that I put in. So it's clearly got 3 capacitors in a can, no question, and the return to the chassis, this connection here, is made with that blob of solder that's not working at all. So so what I'm trying to decide here, I didn't really say this, is should I entirely remove these old capacitors, the 3 of them here in the one can, remove it from service and install alternate capacitors or new capacitors? You know, the simple answer is sure, but the nuanced answer is, well, hold on there, Baba Louie. You want to be careful about what you're doing with these old radios, and fooling around in an area full of stiff wires is risky. So I'm going to go think about this a little bit, but I think it's pretty obvious. I should really replace that guy. Probably not original, but can't be sure. If it's a replacement, it looks pretty old anyway. It has exactly the right measurements on it, quantities on it. 10, 10, and 20. It's probably original, probably old, probably should go. In these radios, my experience is the bulk of the filtering of the power supply takes place in the field coil, and the capacitors are much less important to that. Now, just a little aside, the last video was, from a video making point of view, was just a little bit rough at the start, where I showed an earlier piece of an earlier video where I discovered that my overhead light, which is way up there, which is not on at the moment. How come it's not on? this light here, this ring light. Yes, I know, ring lights generally not supposed to be used in the sky like that. How that caused so much consternation with this radio, and part of the story I did not bother explaining, but I'm going to show you. Here's part of the story right here. Let me just take this out of the way. Okay, so I move this light around all the time. I'm moving it down, I'm getting it close to the radio, I'm moving it over here, I'm moving it up there. I'm doing different things with that light. And as I do, of course, the proximity to the radio is changing hugely. And this is causing varying degrees of interference in the radio, which is causing me to see varying results in my testing, causing me to scratch what's left of my hair out of my head. So that's just another part of the story here, which made it very difficult to understand what's going on. Anyway, so much for that. Yes, I'm going to just ponder a little bit, drink some coffee before I start doing this capacitor. Hey, how about some COVID statistics from Canada just before we get going here? So, like everybody in the world, we're pretty concerned about the most recent news, the new variant that appears to be on the scene. Nobody's too sure what's going to happen with that. But I'm happy to say in Canada, people over the age of 12, let me rephrase that, the vaccination rate for people over the age of 12 is in the high 80s, just short of 90%. So 90% of what you could call the teenage and adult population vaccinated here. We currently have 25,000 active cases. Our population is about 37 million here. We have 25,000 active cases. 480 serious cases. I guess those are the ones that are in the critical care part of the hospitals in Canada. Canada's a large country, so it's not uniform. There's some hot spots in Canada, very scary, and other areas not so scary. So that's the situation here. Vaccinations are rolling ahead. We're vaccinating school-age children. All that stuff is going ahead. Canadians are by and large very compliant people. When the government says, please do this, we say, okay. That's kind of how it operates here, mostly. Just for comparison, 25,000 active cases here. Our neighbors to the south, which are 10 times the size of Canada, should have 10 times the number, should be 250,000, and the number of active cases in the United States is 9 million. 9 million active, sick people with COVID. Oh my gosh. Okay, now I gotta somehow get that out of my head and continue on here. So what have I decided to do? Well, the way I'm looking at this is, can I solder that to the chassis? Probably not. It's probably too tough a thing to try. I have to get out a bigger soldering iron. It's pretty tough to solder to a chassis. This is not brand new in the factory with clean metal. It's been, it's a tough thing. So I probably could not successfully solder that back down. The next alternative is to solder a wire, like to preserve that capacitor, solder a wire from that terminal to a nearby ground terminal, or somehow make a good chassis connection. I see some big screws here holding the transformer in. I could put a connector into there. I could solder to it. That would work out. That wouldn't be too bad. I don't think there's any other terminals nearby. Like the nearest one is down here, and this is right off the chassis too. It's really hard to solder to. So there's a possibility of sort of fixing this loose capacitor thing. The only reason to do that, really, and not just go ahead and replace them, is because all the wires go to this spot, hook up to those terminals, and that's where those wires like to be. And I'm going to get in there, cut those wires, and start trying to install a bunch of these little capacitors. That's unnerving. So another way to deal with this is to leave the old capacitor connected and solder the new capacitors onto the terminals and just parallel it. Now that's not a bad option. There's probably nothing seriously wrong with the existing capacitors. They probably even still have a decent amount of capacity. The radio's not looking for very much. 10 microfarads, not very much in the first place. Okay, so I'm still mulling this over. Obviously, I haven't really settled on what I want to do here. I think the best option for this radio, considering it's operating fairly well and fairly hum-free without with the capacitor the way it is, that all I need to do is secure the ground connection. I think putting in a terminal here is a good idea, and then I can run augmentation capacitors, parallel these with the existing capacitor in there. Now, what happens if? So these are 10s. I'm not going to worry about the 21. That's not a big deal. The two 10s are critical. What if this thing is still 10? If they're still 10, and I go ahead and add another, let's say 10, now I've got 20 on here. What does that do? Well, they take a little longer to charge up initially. They draw a heavier current for a longer period of time initially. Once they're charged up, bigger capacitors shouldn't, I don't think, cause really a problem. It's the initial charge up phase. That current that's charging into the capacitors gets pulled through something. It could be pulled through the field coil. Some radios there's a resistor there, pull through the resistor. Now it's an initial startup, so everything's cold to start, so it has a lot of thermal capacity, so there's room for things to take, you know, a good shot of current, especially since the charge up period is very quick. The voltage that they charge with doesn't appear when you turn the radio on. It appears as the rectifier heats up and begins to conduct current. That, as you can imagine, is a slow process, takes a bit of time. So, but there's another problem that can happen if you have too large a capacitor. And you know, again, always take everything I say with a bit of caution here, because I can be wrong. It can happen. The capacitor looks like a short circuit at the start before it has any charge, and so to some degree you're involving a short circuit on the output of the rectifier tube. Now, that can cause problems in the rectifier tube, including shorting inside the rectifier tube from too much voltage. Now, I'm not sure I'm telling the story correctly, but there is a risk to the rectifier tube in having too large a capacitor there. 10 microfarads, 20. So what if these no longer are 10s, now they're 5s, because they've worn out, if that's a way of looking at it. So if they're 5s, I could return it to 10 by adding 5, then the risk would be low. But I don't know if they're 5s. I don't know if they're 5s, 1s, 0s, or 10s, or 15s. I don't know anything about them. Trying to measure the capacitance there is difficult because they're in a circuit that would affect the measurement. So it's tricky to know what we're up against here. So I mean, the easy thing to do is get rid of it and put new ones in. That's the easy thing to say, let's say, but that's not the easy thing to do. It's not the risk-free thing to do. So another alternative is to go ahead and install the capacitors on the terminals with all the wires left, everything left in place, and then get in there with a pair of cutters and cut the terminals free from the old capacitor. Pull them off a little bit so they won't make contact. And what you've done there is you've managed to install the new capacitors using the wire connections that already exist, leaving all the wires pretty much in the same place. The difficulty with that is getting in and cutting those terminals. You know, in some cases you just can't get a pair of cutters in to do it. I'm not going to cut them. I'm just assessing this now, because you want to solder the new connections before cutting. So, well, it's a little ugly, especially I'm doing it now without these capacitors in there. Once I install those capacitors, it's pretty ugly getting in there. You can always cut them and then install the capacitors afterwards, which is maybe that's the very best way to go. Could cut the wires free without moving them, try to solder to the wires. The difficulty with that is there's insulation on the wires. You have to trim the insulation back a bit. That's a very awkward procedure way down inside here to do. Yeah, I'm still thinking about it. And the last alternative is just fix that ground connection and leave it all the way it is, because I didn't really hear a hum coming from this radio. Could delay this decision until playing the radio out of its own speaker. Right now I'm using fairly small speakers. You can see them up there. There's one up there. That size speaker. That really can't produce the low hum that could easily be present, and we just can't hear it here, so I'm kind of ignoring it, and I've made this mistake quite a few times with radios where I don't think they're humming, and then I put them all back together and go, ooh, listen to that. That's forced me in a few cases where I've finished the video right off to pull the whole radio back out of the cabinet and fool around with it some more and stick it back in, and just don't bother putting it on video at that point. But I've definitely been there a few times. I don't want to be there with this one. So it sounds like mixing all this together, it sounds like I gotta stop again and think a little more before I do this. And now, at risk of wrecking my channel here, I'm going to talk a little more about COVID just for another minute. So, how many active cases in South Africa? South Africa is where the latest variant has been detected. Doesn't mean it's from South Africa. It just means that's where it's been detected first. How many people have COVID in South Africa? About 60 million people live there. 20,000. 20,000. How many people have COVID in the United States? 9 million. Which country is cooking up variants? Well, it's kind of obvious. Jeepers creepers. And I just noticed something else about this radio that's worth looking at a little closely. Having a little bit of trouble calming myself down today about the COVID situation. It's very upsetting to everybody, including me. So let me just grab my close-up camera here. Whoops. Okay, let me stop traveling the dangerous waters here and get back to the radio. Look at this cable. This is a steel cable, not a string. Now, what is it exactly? Well, it's a combination of or is that a string? Oh, I think it's a string. It's definitely, is that dust on the string, or is it giving up the ghost here? I got stuff on my finger. Why don't we just run this right past the camera once and just see if there isn't a really bad spot. Like that's... So when I was a apartment building maintenance man, when I was going to college, see up here, it looks good. And you know what, you see it sliding there. Look at all the pieces of it everywhere. Oh my gosh. Could well be that as I'm working away here, I am literally high speed wearing this string out. Oh my gosh, look at it. Oh, it's just coming apart, isn't it? Every time I've done this, this is what's been happening to the string. Oh no. I feel the string job coming on. It's sliding under the knob too. Never noticed that. Doesn't feel that way. Oh, it's just raining down out of it. Oh my gosh. Look. Yeah, when I was working in an apartment building, we had elevators, and the elevator company guy would come in. This is about halfway through tuning on it right now. And I was curious, so I'd hang around with him a little bit. And one day I encountered him. He was up in the penthouse, which is basically the motor room for the elevators. We had 4 elevators. And there's great big pulleys. You can imagine these cables come up. If you've never seen it, look at how good the wire. Now this is what it should look like. Everywhere. What was that? Something just falling there? So he's looking at the big pulley, something like this, only big. And there's like 4 or 5 or 6 cables that are holding the elevator coming up. They come over the top of this gigantic pulley. He's got some kind of like a protractor or a tape measure or something out. And he's really down close looking at the cable. So I think, oh, look at this, is just totally stuck. You know why? It's probably because the wheel, and you're not going to be able to see it, but way back there, that wheel is pinned the way I've got the, that's what it is. So if that wheel wasn't pinned, this thing, it wouldn't slip on this. This string's going to have to be changed because it's going to break. It's just not going to last. Okay, let me finish my crazy story about the elevator. So I say to him, hey, what are you doing there? He says, I'm counting the breaks in the cable. The what? Because that's right. Yeah, you count, like a cable's made up of a bunch of, thousands of individual wires. And as the cable wears out, just like you saw that string, the wires break. Just because one little wire breaks doesn't mean the cable's shot. In fact, there's a standard, a number of breaks per inch you're allowed. So what you do is, as a technician, you come up every 4 months or something like that, get a close look at the cable, and you actually count the number of broken wires you can see over the course of 6 inches or something like that. And once the number of breaks reaches a certain level, you got to change the cables out. Oh my! that really made me think, holy smokes, really? I just never even thought that, as you're riding in an elevator, the cables are wearing out. And you're just trusting people to do the right thing. And now, elevators are super safe, okay, so there's nothing here to worry about. The thing had 6 cables, and he told me 1 cable was enough to hold it up. 6 cables, something like that anyway. So that's why you don't hear really about elevator accidents, and you also have the elevator brakes and all that stuff. So not really a concern for falling down. Besides, if you're in an elevator and you're all alone, you're in the elevator and suddenly everything quits. The elevator motor goes into neutral, and there's no brakes, there's no nothing. You don't go down, you go up. You go up because the counterweight is much heavier than the empty car. The counterweight equals the car and maybe half a load of people, somewhere in that range, or a third of a load of people. That's what the counterweight is designed for. So if the elevator just lets loose completely, the car goes up and the counterweight goes down. So all those movies you've seen where people are falling downwards, yeah, okay, if the cable's all broke, I guess maybe, but not really. Yes, reality. We must all face reality. It's a good thing to face reality. 9 million people sick. Yeah, let me add just one more piece to that. 9 million people sick in the United States. I could be wrong about this, but I won't be much wrong. That's the highest amount of sickness from COVID in the United States yet. So as a nation, they're sicker now than ever. Yeah. My God. Okay, can't find a little terminal to install here. So I was going to loosen that nut off and stick a wire under it. But what I realized I could do, I just put another nut on here, provided I can find one, and I'll just squeeze the wire between the new and old nut. There's a square one, but I think that's way the wrong size. No. Yeah, no. Yeah. Goes on the distance. So I'm going to find a nut and some washers and stuff like that. I'm going to install a wire coming from here back this way. Now I've also realized that, yeah, it's hard to solder to the chassis. It's going to be hard to do any soldering down in here, but I think it's the best way to go. So I'll solve the ground connection first, and then I think I'm going to do the augmentation thing from there. And I think I'm going to probably use not 10s but 5s. And I've got a couple of 5s right here. 4.7. These are 400 volt capacitors. We've already seen that the voltage in here, when you first turn it on, rises up to about 450 volts for a couple seconds. But I don't think that's really a risk. These things aren't going to blow because you go 1 volt over there. limit, their limit is really based on long-term operation. And okay, so I got there we are, found the nut. Good. Okay, I'll go ahead and do all that. He says, trying to not talk about the thing, the scourge. Stay away from the scourge. Okay, just in thinking about it a little more, I've got this heavy piece of wire. This is a neutral wire from a household wiring cable, and I've buffed it up with sandpaper, get rid of the copper oxide. So I'm picturing this being screwed under this terminal, coming across, being soldered to the can basically of the existing capacitor, and then the negatives of these coming up and catching this wire, which would make perfect sense. Now what I'm thinking is, wait a minute, once I've installed this, soldered it in place, it's way down under there, hard to get at. Maybe I should fit these, like solder the negative side of these onto this, and then install it, and then make the final connection, which would be much easier if these were already one side soldered and, you know, fixed in place and all that. That's what I'm thinking. I'm also thinking it's extremely awkward for me to work at this angle because, you know, from where I am, you're a little short. This is what I'm seeing all the time in this radio. So now I got the camera up at my eye level. So that's where I'm working. So to see in there, I got to get down on my knees here like this. This is no good. I can't work like this. So this is involved enough that I don't need the frustrations of the difficulties with working on it. So I'm going to probably want to rearrange this entirely to make this go a little easier. A lot easier. I wouldn't want you to miss the part where I dropped the radio, so I turned the camera back on. I'm ready to flip it over. I think I've disconnected everything from it. The magic eye is still hanging there. Let's see what happens. We go like this. Go like that. We put it right on top of these capacitor posts here. Yikes. Not the best thing. I get this one up. Oh boy, she's a wobbling. Okay, that's much more workable, except it's just a little bit unstable. It's not bad. Actually, you know what? It can't actually go far. Thumbs up on that. This will make this a lot easier. It's definitely worth doing for sure. Whole thing looks different to me now. Let's pull it over here. Yeah, this is far, far, far better. Get my little capacitors. Piece of wire. Okay, one of the capacitors has wandered on my bench. So we're going to want this wire to come across and solder over here. Over here. So I'm thinking I can attach these in the appropriate spot, and then when I would solder these onto this wire. Put the wire under the screw. Solder the wire here at the other end, right here, and then solder the positives to here, here, and here. You need three. You need three capacitors. Hey, you need three capacitors. Ooh, what about the 21 as a bypass? So it might be worth disconnecting the bypass one. The bypass is probably this wire here, because this is the output tube right down here, and this is probably the cathode resistor, this big one here. So did I ever measure the value of that? Let's continue with the distraction. What is the value of that capacitor? Probably supposed to be something like 270 or something like that. It looks like body end dot would be orange, silver, black. What's that? Orange, silver. Let's see what this says. 'Cause there's a good chance this is not the correct value also. Huh? Huh? What? Oh, there's a... Huh. How did that happen? How did they get a capacitor measurement on a resistor? Are you kidding me? No, this guy really thinks it's a capacitor. A tiny capacitor. Why would you not read the resistance there? Surely to goodness that resistor can't be open. If it's what I think it is. Let's get another one. That's the COVID. And I'm thinking it's probably around 300 ohms, if it is what I think it is. A cathode biasing resistor. Okay. A little hard to see my meter there, but that's going to have to do. So we go on this wire to here. Getting a lot of different readings here. Let's just see if we can stabilize this thing. Looks like just under 500 ohms. 500 ohms. We better check into this. Now's a good time to do it. 500 ohms. It's between pin, it's coming from pin number 8 to ground. Pin 8 to ground. 8 is often on a plate. Maybe it's not what I think it is. Pin 8 of the output tube. So here we are. Pin 8 is right here. That's the resistor 390. That is supposed to be 390. Maybe the 9 is the silver color. And the third was black. Yeah, that's supposed to be 390 ohms. And I'm measuring it at 500. That's got to go. That should be changed out too. Okay, more to do. The reason there isn't a little electrolytic capacitor installed down here is it's cheaper and easier to buy that canister with the 3 capacitors in it when they're designing and building the radio and do this kind of thing, because electrolytic capacitors were expensive. Still are a little bit expensive, but not like they were. It was much more difficult to build a electrolytic capacitor back then, and so packaging them all together made sense. But today it doesn't make sense. Today I should put the bypass capacitor over here and sacrifice it from here, and that reduces the number of capacitors I've got to put here. That's a thumbs up. Took me a long time to come up. Takes a long time for the good ideas to displace the bad ideas. You got to give it time. Am I still in the bad ideas here? So new resistor and a capacitor installed right there. Well, I thought I was going to do all this before I turned the cameras on this morning too. And that's reminded me, this radio has the wrong output tube in it. It has a 6K6 instead of the 6F6, and I wanted to experiment with a 6V6. These tubes all have different biasing, I would think. I'm going to look into that, just see what I'm getting myself into, especially if I'm going to put a 6V6 in there rather than the 6K that's in there now. I'm going to check that out. So I found that 9 million number so unbelievable I decided to double check it. Now I got the 9 million number from a website called Worldometer, and I've been following that pretty much throughout the whole COVID affair. But 9 million, I'm thinking, well, maybe they're just not tracking that thoroughly in the States for some reason, and the numbers just going up, and they never reduce it as people recover. So I checked on another website. It's not 9 million. It's 9,400,000 currently sick people in the United States. Active relatively sick people in the United States. So I was watching CNN just now, and they've got a guy talking about South Africa, and he's talking about the cases in South Africa, and I'm thinking this is no different than seeing somebody standing on the sidewalk of a street, and there's a house on fire behind him, and he's talking about some children playing with matches across the street. That's very much what it's like. The American house is on fire. Yikes. Well, I'm going to have to change the rating on my video talking about all this stuff. Yeah. Okay, where am I getting to? Oh, I did get somewhere. Did I not bring... Oh, I didn't bring the paper in here to talk about the tubes. Let me go get it. Just like everything in life, nothing is really very clear. So here's the 3 tubes I'm considering. This is the one the radio's calling for. This is a little bit rare. This is the one that's in there, and this is the one I have many of, and this is apparently, from what I read, is an okay replacement for this guy. So I've picked up some key statistics here from each tube. The one I was really after was how big should the cathode resistor be. So for the 6F6 running at a 250 B plus voltage, the cathode resistor should be 410 according to the RCA tube manual. So maybe it's not 250, maybe it's lower. So this would be a little bit lower, but not much lower. These 2 tubes in the tube book do not quote a cathode resistor for reasons I don't know, but there's no cathode resistor. So I started writing down the expected bias voltage that you should be operating these tubes at. And you can see there's quite a difference there. 16, 18, and 12. 12 for the 6V6. So what would happen if you put a 6V6 in with a 410, or what I was going to put in according to the schematic? Where would you end up with the bias? I don't know, question mark. The other thing I looked at is the quiescent plate current, or the no signal plate current. That's something worth taking a look at. You can see the 6F6 will idle at 34 milliamps, 6K6 32 milliamps, 6V6 45 milliamps. That's quite a difference. That's quite a difference. That's going to have a bearing on this, which isn't quoted in the book. But then I thought, what about the heater currents? So you can see the 6F6 has a heavy heater current, 0.7 amps. These 2 guys have less. This is quoted in the book. It just mentions its application is for a high power output. Now this one talks about medium power output, and I don't know what this one said. I forgot. So it's not just a simple matter of popping these tubes in and out. So putting this one in, cut the heater current back, which is a good thing in a way. Well, I would have to measure what this is. It doesn't give me a hint on what the cathode resistor could be, but you know, if I knew exactly what the B plus was, and I knew a bunch of other things, I could calculate what the correct resistor is going to be. It's going to be, you know, 300, 350, 400, 450, somewhere in that range. 6K6 is in here now. The radio seems to be operating. I don't see we're glory bound by sticking a 6V6 in there. In fact, we've got a couple problems. I got this problem if we stick a 6V6 in there. I'm just going to leave the tube that's in there for now in there, not sweat over this. I'm going to change the cathode resistor to what is specified in the schematic, and not that value. It's a different value, and we'll run this, and we'll measure what the bias is, because we know what the bias should come out. And if I got the wrong size resistor in there, I guess I could change it. And I just don't know off the top of my head what the B plus is. I can't remember. Something like 250. Okay, so that's basically a long way around to saying I'm not going to do anything about the tube, but I will change this resistor, because at 500 that sounds pretty high. Okay, I got a new plan. New plan. Operate the radio as it is. Measure these tube voltages. Measure the drop on the cathode resistor with the 6K6 in there. Find out what the bias is. Just find out what the B plus is, and get that little bit of information before going ahead and doing something. because, you know, maybe it's all okay even with this bigger resistor in there, and I'd be best to just leave it all alone. So got to find out, bring a little certainty into the picture here. So I think I can just keep the video running here. So I'm making a quick check to make sure it's safe to operate. I've got the push buttons unplugged, I've got the antenna unplugged, the speaker's still connected, of course. So I don't think there's any problem with operating the radio. We're just not going to hear anything from it. That's okay. And then I'm going to want to have this meter ready to read some voltages. We'll start with the B plus voltage, 2. And you know, it might be interesting to put it on the indicating meter over here, because there's an initial rise of voltage that goes way up, and I've noticed it a couple of times, and it might be good to get a grip on that. So to do that, to get that grip, I need the voltmeter leads here. I'll use a clip lead. And we need to go on the plate. Oh, which one's the plate? I'm going to stop the video and I'll get this set up so we can do it. Okay, ready to go now. So this is the plate voltage. It's pin 3 on the tube where the clip lead is. And what I'm expecting this thing to do is to rise up almost to the top of the scale here. It's 500 volts here. I think it's going to come up to 450 right about here, and then go back down. But I really want to spot how high it comes, even though it's brief, and then we'll see where it settles in, and that'll tell me the plate voltage on this tube. We're going to hit the thing with full Niagara Falls right from the start here. Actually, we're going to use the Darlington nuclear power station this time to power the radio. Everything ready? I think so. So nothing should happen, and then when the rectifier tube heats up it should come, and then down. It comes down because the other tubes start conducting and drawing current, and the regulation on the power supply is not very good. So it should settle in where it's supposed to go. Are we ready? I'm hesitant. Why am I so hesitant? Because that's just my nature, being hesitant. Okay. All eyes on the meter. 500. 500. Coming down. Looks like it's going to settle in at 250. 500 volts. So every time you turn this radio on, this thing takes some of the circuitry takes a 500 volt push. Wow. Okay, so about 240 to 230, somewhere in that range. B plus. And now we want to measure. To be careful here. This clip lead has a lot of volts on it. Lots of volts. Let me take it off here. I think I can do this. That spark's flying. Good. Okay, now we're going to go at that and test the grid, or the bias voltage, basically. That's going to be a negative voltage. It's going to be fairly small. We'll start at 50 volts on the meter. I'm going to move the camera on account of it's in the way here. Okay, so now we're on a 50 volt scale. I would expect this only to come up in this range here. That's what I would expect. What is the bias? What happened here? How do we end up with a positive there? So I've got this set to negative. I expect it to go up. What am I doing? Am I doing something dumb? Ooh, how can that be? How can you get that kind of voltage there? Oh, that's right. Yeah, it's going to show positive when I do it this way. That's right. Okay. Now I'm not touching the grid. I'm touching the cathode resistor. So this is the voltage the cathode is lifted to. So yeah. Okay, let's read it again. Not be so panicky. 15 volts is what we've got there. 15 volts and 15 volts. So see, it might be a little extra negative because it's a little bit of a large resistor there. 15 volts, and what are we looking for? Well, 6K6, we're looking for 18. We only have 15. It's actually low for that. Jeepers! If I lower that resistor, this number's going to go down. What happens if I just pop in a 6v6 and do this test? I don't like that. That part. I don't like that part. Well, so the less negative the bias, the more through current. So this 32 milliamps is at minus 18 volts at 250. So we know this is a little bit lower. If I drop that resistor, I think I'm going to reduce this. I'm going to increase this. The only other really question about this is, and this is a good thing. There's some goodness in this tube. The only real question is this radio distorting because the tube is, improperly biased or just so far out from a 6F6 that it really shouldn't be in there in the first place. I haven't noticed anything like that. Leave well enough alone. Maybe that's what I should do here in this situation. And get back to what I'm really trying to do. First, turn this radio off because there's no sound. Goodness knows I'll stick my fingers in it in a moment. Then there'll be some sound. That's for sure. Okay, so what my decision is, leave everything alone on the output after all that. Just leave the tube there, leave everything there until there's some indication that there's a problem with it operating this way. That indication will come only after I install the proper speaker and really get this thing going back in its cabinet. Ooh, that's a bit of a drag. There is another way of checking this, and that is to scope the output of this tube and then drive up the signal on the grid and see if it starts cutting, any cutoff starts happening or something like that. That's all fine and dandy. I think I need to get back to what I was doing originally at this point. I think that's the journey I had to take on the output tube. I can continue thinking about it, so I'm going to go back. Let me pull this out here, just double safety here. I think I'm going to go back to just working on this. Try to get something done. I got to get something done here. Get something done. Okay, so I've managed to install a bypass capacitor here, and that means this wire is no longer needed. We're going to get it out of here. A little hard to cut it all the way back. Just cut it right here. Someday somebody will look in this radio and they'll see this cut wire and they'll wonder, oh, where's that supposed to go? Good show. Just bend it up a little bit. Leave it sticking out there. Great. Got to do the capacitor thing up in here. But oh my gosh, it's almost lunchtime. Wow. Got so many little tiny logistical issues here with doing this. What to do first, second, third, all that kind of stuff. I think the best thing I can do is bolt this in, bolt in my little wire. I mean, not the least of the considerations are, where can you get your hands and stuff like that. I want this to go over like that. There. Pinch it closed. I'm going to drop a locking washer on top of it. And drop that nut on top. sure if I've got a tool that's going to follow that. That's no good. All the way down. Is it doing anything? Yeah, it is. Okay, so now we want to get this into the right position over here. Like that. Crank her down. Perfect. Okay, that's a lovely ground connection there. That's a beauty. Now I gotta solder this. Maybe before. Okay, should I solder that first? I think so. It's pretty clumsy to get in there and make this thing solder down. It's almost like soldering it to the chassis. I wish I could increase the contact area there. Okay, I need a big whack of solder and a hot soldering iron to get that on there. Then I will attach these. Kind of come in this way. Attach the ground, the negative side, to the copper wire, and then the other two to the two remaining capacitor leads. And these are phi's, half of what the radio's recommending. I'm sure there's still capacitance in here, in those capacitors too. So yeah, okay, just got distracted. Boy, I distract easy. Yeah, the distraction was seeing some of my bad soldering jobs done because I had the radio in a very awkward position. But now I can see and access things quite easily this way. And this guy looked pretty bad. There we go. That's better. There's another one that looks terrible. So sometimes I go through and make pretty quick connections, and then come through at the end of the project and just look them all over and fix up any that look bad at the very end. And, here we go. Doing it now though. It's better. That was actually okay. There's another one here that's very poor. There. Wait a minute, this isn't the one. Better. So in a manufacturing environment, you can't afford to have any loosey-goosey approaches to anything, because if you're going to make 1,000 of these radios, you're going to have quite a few with trouble in it. If you're doing just one radio yourself, things don't have to be done nearly as good. So you can have airborne connections like this. You can do stuff like that when it's just a one-on-one thing. Okay. Carry on over here. Let's see. Okay, I might as well let the camera run. So most of my videos I post are around an hour long. Some are a little longer, a little less, but most come out around an hour. That's not because I'm trying to make them an hour long. That's what they come out to, running or working. I don't try to constrain myself too much, although I have a personal limit of how much I can do this in a day. I have other things to do too. Oh boy, look at this. This is not going to go well, I don't think. There's a lot to heat up down here. Yeah, I got a big fat wire up against a cold chassis, sort of. Yeah. So this may not work out well. I have to bring in a different soldering iron, because you want this connection to be pretty darn good here. Okay, that's a good soldering iron spot. I'm going to give it some time for the heat to flow and the temperature to rise. Right? Heat and temperature, two different things. Oh, it's working. You got lots of melted solder here now. Let's put some more in. Lots of solder there. Ah, that's good. Okay, that's going to work. So we solved the loose ground connection. Now the next thing is to put in the two little capacitors here. So just let the video roll. You know, if I turn the video off, I'll leave the shop and go watch TV. Actually, I'll go eat lunch now. I'll leave these positive leads long for now. Kind of hold together long enough to get them on the wire. I can stick them down here. Stick them around like that. Uh-oh. So the copper wire, I don't know if I mentioned it, I sanded it quite a bit before installing it to get the copper oxide off it. And good move. There we go. Pretty hard to see what I'm doing here. Okay, that's solderable. Getting pretty tight in there. Oh! Don't know if you heard that, my stomach growling there. And saying, what are you doing, man? It's lunchtime. So the first shot, just to tack it kind of in place. Great big copper wire. I can solder the other ends and then come back and really solder this up well. I need it tacked. Oh, for crying out loud, my soldering iron timed out. It thinks it's lunch too. And that's not the right button. There we are. Okay. Not going to be able to solder it with a cold soldering iron, that's for sure. Okay, 330 degrees C is where I've got my soldering iron. I want to make contact with that big copper wire and to really drive the heat into it. Yeah, it's starting to flow a little bit. Okay, I think that's tacked on there. That should be enough for me to make the other connections. This is my plan. Did it pop No, hold on. Okay, lift up, guys. Okay, so I'm gonna need a little tiny piece of covering here. Here's one right here. Okay, then we want to go down to that terminal. You're standing right in my way here. Down. The tool I'm using here, this was given to me as a gift by my first girlfriend's father, who was a mechanic. I was in high school. Gave me this nice toolbox and just three of these really nice tools. Here I am, still using them. Married somebody else though. Maybe if you'd given me more tools. He was a mechanic. He kind of liked me because I was oriented that way. That's one. One done. One more to go. It's even tighter for the next one here. Way too much wire here too, so let's get rid of some of the wire. This goes down. So, let's get a little more grip. Okay. I'm actually going to get something done. Do you watch a guy on YouTube whose channel is called Vertasium? If you do, you may have seen his video on electricity and power or energy flow, and he's got a setup, I mean just a thought experiment, battery, switch and light, but the wires going to the light are 300 million meters long. They're one light second long. So how far would light go in 1 second? I think that's soldered. And then he says, okay, close the switch. That's a battery. How long before that light goes on? Have you seen this video? I see a lot of other subsequent videos being made by other people taking a shot at answering it. And I personally think they're all kind of wrong. Okay, should I attempt to resolder the negatives? They seem to be on there pretty good. This all seems to be pretty good. I kind of like it. Yeah, he has a strange, in my view, a very strange idea about how electrical energy flows. Because of the electromagnetic field, which is carrying the energy. I don't know if you've seen it. I'm tempted to take a shot at answering this question too, but I just don't. Anyway, enough muttering about that. So Vertasium, lots of great videos done by this guy. But this one he did is pretty controversial. What he's saying, I think. Pretty questionable. Okay, I'm just looking over all the soldering in here. All looks pretty good. I think that's it for today. I'm going to test the radio tomorrow because I'm done. I'm done here for today. Great. Kind of another weird journey in my shop, but lots of good stuff happened. So another step taken. Great. See ya.